Welcome to Oppenheimer, Science, Mission, Legacy. Our docuseries will explore Oppenheimer's career as the first director of the Los Alamos National Laboratory. We hope to share with you a new perspective on Oppenheimer and make the connection between his mission during the Manhattan Project and our mission today. Oppenheimer's story is of significant challenges, outstanding accomplishments, and the beginning of what we call big science. It is also an important story that continues to influence our scientists today.
Was he a hero? Yes, I think he deserves that title. But like all heroes throughout history, he was a flawed hero.
You had the drive of wartime urgency. The laboratory under his leadership responded to that.
They came to a design. It was pretty novel and pretty innovative. And because they weren't actually sure it was going to work, they needed to do a test.
And when he's in the bunker at Trinity, he's clinging to a post, shaking, because it's all come down to this moment. It succeeded, but it cost him.
Fat man, little boy, they were not weapons of deterrence. They were weapons to end a great conflict.
We begin our story by exploring Oppenheimer's contributions to science. But first, who was J. Robert Oppenheimer?
I think one of the most interesting historical aspects about Oppenheimer is his complexity. And over time, I've sort of tried to divide that complexity up a bit so I can understand it. So I have him as a pre-war character, as a wartime character, and as a post-war character. And you see pre-war, you see a precocious individual, somebody who is brilliant even as a child, who does not have a normal childhood. He himself said that he had no normal way of being a normal bastard like other kids. He just didn't have that kind of lifestyle.
I think both Robert and Frank and the family just really had a natural interest in how things are. Where does this, not to get a good grade or to go through school at a certain level, but just absolute fundamental interest. I think in the family I heard about his rock collecting, sparking his interest in science, and I love that. It's just such a, interest in rocks. Where did this come from? And why do we have rocks? And what is the earth like? Then led into geology and chemistry and physics just through a natural exploration of what interested him. And he was, he was gifted and different, and like he was in a situation where that was okay and he could pursue it.
Go ahead, please.
J. Robert Oppenheimer is one of those characters cast in a movie of high drama. He was an unusually gifted, unusually intelligent young child. He was the child of Jewish parents. His mother was a native-born American. His father had come to America from Germany and had made quite a bit of money.
He started his career during the Depression. He could see a lot of people around him who were struggling. Then the war came, and then ultimately Pearl Harbor and becoming part of the war itself. Those must have been very complex issues for the academic community, for individuals.
He was the chosen one. He was so bright, so gifted, so entertaining that his parents indulged in virtually anything that he wanted.
Oppenheimer's early years were spent studying abroad, and his early accomplishments have influenced today's scientific community. However, when it came to science, he was truly ahead of his time.
Astrophysical objects and the structure of astrophysical objects under extreme conditions, particularly conditions like black holes, quasars, and the like, are of fundamental concern today. And Oppenheimer was one of the very first to predict the continuation of gravitational collapse back in the 1930s. In the opinion of many prominent theoretical physicists like Hans Bethe and several others, was that he might well have won the Nobel Prize for those endeavors, but they were quite far ahead of their time. And even when I was in school in the 1980s and 1990s, black holes were recognized to be a theoretical object, but were not yet recognized as being something that exists in the real world. Now, not only is it known that they exist in the real world, they exist in profusion in the real world. And so that's a linkage directly between some of Oppenheimer's first work on theoretical physics and current problems today.
A lot of the same kinds of scientific thought and same kinds of processes are important for particularly high-energy astrophysics or supernova astrophysics that are important in nuclear weapons. People who work on supernovae and nucleosynthesis, they deal with very energetic systems, they deal with nuclear processes, they deal with complex fluid motion, complex hydrodynamics, and a lot of those can play an important role in understanding our nuclear weapon systems too.
Oppenheimer made a number of scientific contributions. Certainly in my own field of condensed matter physics, he's famous for something called the Born-Oppenheimer approximation. It goes to how we think about how electrons and phonons interact in solids. He also made a number of similar contributions in nuclear physics and nuclear science.
The field of theoretical physics was evolving in Europe. Oppenheimer gravitated toward theory and played a significant role in establishing the American School of Theoretical Physics, which gained prominence in the 1930s. He was a brilliant advocate.
In the 1920s, physics was much more of a club. There were very few physicists actually in the entire world. The famous 1927 Solvay conference, I don't know, it had maybe 30 physicists altogether. Then these were the leading physicists of their time.
And he happened to be in Germany at exactly the right moment when theoretical physics was taking an enormous leap. It was as if somebody had opened the door to a magic room and suddenly the human mind was able to understand physics.
I think the work that the best theoretical physicists do is develop an intuitive intuition for how things work. They can take a limited set of data, a set of known observations, and at the chalkboard level, sketch the underlying phenomenology that's being explained. That ability to derive an insight, to say, I get it, this is this phenomena, here are its basic properties. When that happens, that's a pretty special moment in time. I think those moments happened early in the days before the Manhattan Project, where the leading scientists of the world, including Oppenheimer, knew this was pretty special, had both an understanding of the phenomena and knew its consequences. And that was probably an element of the origins of the Manhattan Project.
When he came back and joined the academic community here in the United States, one of the things that I think weighed on his mind was, how do we make American universities at the same sort of quality scale as what he experienced as a student in Europe?
What his major contribution was before Los Alamos, it was establishing in America and on the West Coast America's leading school of theoretical physics. It was, by the time of the start of World War II, the center of theoretical physics for the world.
Today at the Los Alamos National Laboratory, scientists continue pondering the natural world as they explore the power of the universe.
Certainly the laboratory has made singular contributions. There are individuals who've just had amazing ideas in that redefined fields. But the bulk of what we do really is the scientists of the laboratory with their collaborators coming together in a teaming way to solve big problems. That's a feature of Los Alamos science. I think that's a feature that was first created, first envisioned in the Manhattan Project due to Oppenheimer's leadership.
What we do really is we're kind of integrators across a lot of different fields of study in the laboratory, where I need to take assessments from maybe people doing work in high explosives research. There's people who are doing work fielding experiments with those high explosives. There's other people developing models, how we numerically conceptualize what's going on with the high explosives. We're working with lots of different teams and different groups of people across the laboratory. And that can be really rewarding because you realize the depth of knowledge that all these different people have is really impressive. It's really substantial.
In my mind, the importance of what this laboratory does for the nation and for the world is as great today as any time in its history. And I think that the kind of environment, the kind of attitude toward questioning that Oppenheimer put in place is going to continue to serve us as we tackle problems that may be harder than any we've had to tackle in the past. And I suspect that their solutions will be needed urgently.
Was J. Robert Oppenheimer a genius? He likely was, and in various ways. His brilliance included not only his understanding of science, but in his teaching method and his ability to lead other scientists in fields he was not familiar with. All these attributes will come into play as he becomes the first director of Project Y in Los Alamos, New Mexico, an integral part of the Manhattan Project.
I don't think Oppenheimer ever took an IQ test. If he did, he would have aced it. But I think the way you understand his intelligence is by the rapidity of his mind. But probably the quality that stood out most for individuals was a quicksilver mind. His ability to listen to different threads of an argument coming from different directions and different disciplines, pull them together, assess their meaning, and come up with a synthesis that everybody that turned and listened at the end of it would say, "Of course."
I had the opportunity to talk with Kai Bird, co-author of American Prometheus, the Pulitzer Prize-winning biography of Oppenheimer.
He was painfully aware of his own intelligence, and I think at a young age didn't know how to funnel it. There's a story in the book of him turning to a classmate at the ethical culture school and telling this young girl at the age of 10 or something, well, ask me a question in Latin and I'll answer you in Greek. So he often came off with, well into his 20s as a young man who was a little strange and arrogant and full of himself. But as I said, he had a sort of fragile psychological personality. He was socially awkward.
Fission was discovered in Nazi Germany in 1938. Months after this discovery, Nazi Germany invaded Poland, starting World War II in Europe.
Fission was enormously earth-shaking in the fact that an atomic bomb was readily apparent. There was just no question that if you split enough atoms, you would release an enormous amount of energy. And in fact, Robert Serber tells a story of walking into Oppenheimer's Berkeley office and finding a crude sketch of an atomic bomb on his blackboard. So it was known immediately by almost all physicists that somehow this was very possible.
At the heart of the atomic bomb is this profound realm of science.
The 1930s were a unique confluence of rapid experimentation and knowledge acquisition in the sciences, and a continuous and alarming darkening of the world from a political perspective.
The United States had not been an active combatant in World War II, but that changed on December 7, 1941, when the Japanese attacked the American Pacific Fleet at Pearl Harbor. American scientists would now go to war.
Up until about 1941, certainly December of 1941, the United States had no interest in going to war.
As we approach towards 1941, and then the U.S. being drawn into war, all of a sudden work on this mysterious weapons intensifies. More of his colleagues are disappearing. He knows where they're going. He knows that it's somehow related to this bomb. He wanted to be a part of it. And one of the characteristics that I think is sometimes underplayed about him, he was ambitious. He really did want to make a significant contribution. That was important to him. And he saw, with now America in the war, and with the possibility of a weapon that could be used against our country, he saw this as a central threat.
Today, laboratory scientists continue exploring complex nuclear phenomena to improve the present U.S. nuclear weapon deterrent.
Fortunately, we've not used a nuclear weapon or an atomic bomb in anger since World War II and the Manhattan Project. But the existence of our stockpile has led to world stability. Countries have chosen not to behave in inappropriate ways because of the threat of nuclear weapons. And so the current nuclear stockpile plays an important role in national and international security, even though we haven't used them.
In the fall of 1942, Oppenheimer was introduced to General Leslie Groves, the commander of the Manhattan Project. This meeting would change Oppenheimer's life, and it would also change the world forever.
When the laboratory, a secret laboratory, became a possibility, he wanted to be the man to direct it. The man who was going to make the choice was General Leslie Groves, the director of the Manhattan Project, who Oppenheimer had met earlier and had very carefully courted. Oppenheimer told his wife, "I am courting him like a girlfriend." As the war neared and then Pearl Harbor occurred, all of a sudden security, particularly regarding government work related to defense, the levels of security and the demands of security rose. The interesting thing about General Groves is that the more time he spent with Oppenheimer, he saw him as the man to lead the laboratory. His ability not just to understand chemistry and metallurgy and physics and all the other dynamics involved in fission research, he knew all the major players. He knew everybody who was anybody in science, just including all of the European refugees. It made sense.
Oppenheimer was essential in convincing General Groves to build his secret weapons laboratory in Los Alamos, New Mexico. As 1943 began, this beautiful mesa top would become home to some of the world's most brilliant scientists.
New Mexico is one of those themes in Oppenheimer's life that people probably don't pay as much attention to. When the war came and the Manhattan Project began and the necessity of finding an isolated laboratory for work on the atomic bomb, when that issue arose, Oppenheimer remembered Los Alamos. Many places for the laboratory were considered. So for better or worse, Oppenheimer is not just the father of the laboratory, but the man who brought the laboratory to Los Alamos Mesa.
So when General Groves tapped him to lead the lab, it looks to me like he sort of said, well, now I have to do that same thing, creating quality in a project that's never existed before, in a setting, that's a laboratory that's never existed before. And I think wisely, Groves gave Oppenheimer a relatively free hand to do that.
The scientific workforce, right, that they had, the initial people that they were trying to recruit, a lot of them came from more cosmopolitan cities, they came from university settings, and they were just sort of dropped into New Mexico. But when you read the oral histories and the accounts of the workers who were here, a lot of people just really talk about they loved being out west, they loved their little tiny bit of free time they had. They could go hiking, they could go skiing. For them, I mean, it was war. It was wartime conditions, and they had to work hard. But it was just a really, to them, it was like a magical experience. You know, if you think about it, you lived in the East Coast, you'd never been out west, and then all of a sudden, here you are in New Mexico, in 1944, 1943. Think about that. It would have been almost life-changing, really.
Oppenheimer was born in 1904 in New York City. Coming from a family of privilege, he was able to travel to the West on many occasions in his youth. He loved to visit northern New Mexico and soon purchased a cabin in the Sangre de Cristos just outside Santa Fe. He fell in love with the terrain, history, and the people of the region. He would create his laboratory here and be inspired by the land he had come to love.
His father sent him off as a teenager one summer to New Mexico. Accompanied by a teacher. And Robert fell in love with New Mexico and the high plains and horseback riding, and so much so that later in life he told his younger brother Frank that his ambition in life was somehow to combine his love of physics with his love of New Mexico. Well, he did. He succeeded fantastically in doing this.
Interestingly, New Mexico was a place that was burned into his heart. For an intellectual, a big city intellectual, an urban child, it seems almost like a contradiction. And yet when he came here and he dressed in his jeans, and his riding outfits, in his boots, and his pork pie hat, this was where he belonged. I don't think California, for all of its charms for him, or Princeton, which is later where he spent the rest of his public life, They never really had the same kind of meaning. They were places he lived, where he worked, which he enjoyed, but they weren't New Mexico. New Mexico was the place in his heart.
By 1943, World War II had taken millions of lives all over the globe. Oppenheimer's challenge was leading top scientists to quickly manufacture and develop an atomic weapon to help end an increasingly deadly war.
The collection of minds that was present on top of this mesa in those 2 years in the 1940s was truly remarkable. There really has not been a collection of scientific minds like that, to my knowledge, anywhere since that time. The Manhattan Project made physics and science in general an object of concern for governments because of its practical application, right? And so that was actually something that was entirely new and entirely unique.
The fact that he could bring together not only the country's but the world's best scientists to build a team to pull off what they pulled off in just a couple-year period, I think that speaks more to, let's call it, Oppenheimer's secret sauce than any particular technical contribution. The body of work that got accomplished here in Los Alamos in a very short period of time, going from underlying physics we didn't understand to actually producing a product, a device that worked, that's pretty amazing. And I think Oppenheimer, as a leader, as well as a scientist, deserves a lot of credit for those contributions.
But I mean, you just think of some of the greats in 20th century physics and mathematics. You had Fermi here. You had very young physicists like Feynman, who was going to go on to demonstrate his greatness. You had people like Bethe here. He was able to attract Johnny von Neumann, one of the truly great mathematical minds of the 20th century. And I think that was part of what his vision was, of creating a place where the physics in the United States would rival anything in the world. But then that's what he needed to be able to accomplish what he did in the Manhattan Project.
Oppenheimer's scientific legacy remains very much a part of this laboratory, and today's scientists face significant challenges and are solving big problems only this laboratory can solve. The concept of big science is rooted in Oppenheimer's mission, and big science continues.
We do big science, and we always have. And that was why the laboratory was formed in the early 1940s, was to do the science needed in order to develop the atomic bomb. And that is still the type of work that we do, right? We still specialize in science that's too big to be handled by other institutions, that's high risk, high reward, that requires the skills of many, many people and requires integrated interdisciplinary teams to realize a common goal.
He's the man that does change the world. It changes how we think about politics, international relations, and diplomacy, even today.
He was a great teacher of theoretical physics. And if Niels Bohr was the father of the quantum, Oppenheimer was the prophet and the educator. He's just one of the most intelligent men of the 20th century. And when I say intelligent, I mean in a very human sense. Not that he was just quantum physicist, but that he was a gentle human being who was a philosopher. And that's a rare thing and a fascinating thing. How do you hold those two strands of human thought in one head? And Oppenheimer was that. He was constantly curious about the physical world and yet constantly thinking about the consequences of science. And he was a gentle soul.
It's this superb talent that we're able to bring together in an environment that allows one mind to sharpen another and create results that just don't happen anywhere else. And what Oppenheimer did with the team that he brought together was he created results that fundamentally changed the world.
In our core nuclear weapons mission, we continue to steward the nuclear stockpile that is the legacy of the Manhattan Project. So the challenge for science is to have as much confidence that our weapons are going to work. Our confidence has to derive from science being brought together in various ways to still have that confidence without using our product for an intended purpose.
If theoretical physics is in fact the answer to the universe's secrets, then he's a man of the secrets of the universe. I would hope that what people would take away is that this place at that time developed something that gave a gift to men, and like all gifts, the Greek notion, every gift from the gods has two sides. Beware what you ask for. So it was a weapon that would end the war and all wars, but it would mean more than that. It's the more than that that I hope people understand. It isn't just about bombs and airplanes and wars. In the very end, and I'm sure this is how 100 and 200 and 500 and 1,000 years from now, we will be looking back at this as an exercise of the mind. And despite all the magnificent discoveries of 1,000 years from now, for all the cures for all diseases, all the new kinds of energies, the men and women of tomorrow will look back at this place and this time and these men and women, and they will think, I'm envious.
Oppenheimer helped establish the American School of Theoretical Physics after receiving a world-class European education. He helped set the stage for partnerships between government, academia, and industry on a truly unprecedented scale. Next time on Oppenheimer, Science, Mission, Legacy, we will explore his unique leadership style and his mission to help end World War II.